about much of these in class, and I've just chosen a few on this page. This is actually a download page, and I'm not asking you to do all of these. I think you can muddle through this enough on your own, you get the idea. But I've asked you to do number 7, and number 7 is a distance, rate, time problem. We have 2 trucks starting at the same point and traveling in opposite directions. And the question is asking, how long must they travel to be at least 672 kilometers apart? So this would be an opposite problem where the rate time of one object plus the rate time of the other object, and we're asking when will they be at least 672 miles apart. So this would be, you would solve that inequality to get your answer. Let me put that so that it comes on the screen. So for number 7, you would have the rate time of one plus the rate time of the other greater than or equal to 672. And you would solve that inequality. Next, I ask you to look at number 9. So you have 100 marbles. Some are red, some are blue. If there are no more than 1.5 times as many red marbles as blue, how many of each color? So there's the key phrase in this problem. And you can let your variable either be the red or the blue, it doesn't matter, and then the other variable would be, or the other color would be expressed as 100 minus your variable. And the way I chose to set this up, which might help you, I said that the red was less than or equal to 1.5 times the blue. You don't have to do it exactly the way I did, but that's what I chose to do. And then I solved. Then of course you should get integer answers since you're counting objects. And then finally, number 11, the length of a rectangle is 4 centimeters longer than the width. So your length, and we've been doing this all year, width plus 4. And then you're told that the perimeter is at least 48. So the perimeter is at least 48. So that means that the perimeter could actually be larger than that. So you're trying to find the dimensions for the rectangle, the smallest possible dimensions to give you a perimeter of 48. Moving on to absolute value problems, word problems. Absolute value word problems are used in the real world, and you can read the problems, and they're pretty much common sense. But to try to make a correlation between the real world and what we're doing in math class, that's the importance of the problems. And the ideal setup or the basic premise for an absolute value inequality word problem, inside the absolute value bars, you would have your ideal situation. You're taking the difference between the actual measurement and the ideal measurement to represent whatever it is you're trying to measure. And then that would be less than or equal to a specific range, a specified acceptable range. So if you're doing quality control or testing, testing things for quality control, you can only be so far out of a certain realm before you get into false advertising or before you create a product that's unsafe or unhealthy. And of course, this is your and conjunction scenario, so that means that you will have a range of values between 2 boundary points. And you can see the bonus at the end of the download. I ask you for bonus to research and find a real-world model that would use an absolute value setup such as this. And you need to be prepared to explain it to the class. You need to cite your source, write it down, have the math with a little description of what it is that you've researched to have an absolute value model for. And I'll do problem number 1, the ideal diameter of a piston for one type of car. So I have my ideal measurement, and you can see this is a real world relevance. This is the diameter of a piston. The actual diameter can vary from the ideal by at most this measurement. So to follow the model that I've set up, the actual measurement minus the ideal, so the actual minus the ideal, must be less than or equal to this acceptable range, and the range is given in the problem. And I will let you take that background information and set up the inequality that goes with this, and then find the specific boundary points, and then present a little graph so that you can see all of the range of acceptable diameters for this particular type of piston. And then let's look at number 4 together. Number 4, you're actually given the 2 boundary points and you're asked to work backwards. So Nestle guarantees that this box of candy weighs between 155 and 185 grams. So these are my 2 boundary points. So any box of candy produced by Nestle, this particular type of box of candy, should weigh in between these ranges, including the 2 tails. So to write the absolute value inequality, and once again my model is my actual, the difference between the actual and the ideal should be less than or equal to some specified range. So the way to find the ideal weight in this problem, actually I think I will let you all think about this on your own. I've given you, you know how to look at the graphs, and you know how I've been doing it in class by finding the center of the graph. So I will let you work backwards with this, just giving you this bit of information. And here's the bonus. So I encourage you to take me up on this because there are so many relevant real-world examples that use absolute value ranges. And just be prepared to go with that at the beginning of the week.